Hey everyone, I'm Vito. Today, let's look at component and services reusability with JAMstack, Azure, and Microsoft Graph. JAMstack is cool for me because of reusability. Instead of creating your own long-winded JavaScript, just use an npm package. Instead of creating your own authentication API, use Azure AD B2C. Instead of creating your own markup, use React components. These are the building blocks of JAMstack, and to me, why JAMstack is so exciting. Let's dive into each of these deeper in a bit, but first, let's take a look at why reusability is important, not just for developers, but for teams and companies as well. So why is reusability important? I'll summarize it as three things: developer experience, developer velocity, and quality economy. These three things are closely related to one another. See reusability in action. Let's have a little bit of fun with Visual Studio Code. Remember in your school, in your computer classes in school, there's always this assignment about um, drawing with ASCII. So I mean, this is back in the 90s. This is like my school anyway. Um, so yeah, let's have a shot at drawing an ASCII portrait. So here's a photo of me. Let's split this to the right. Okay, and then create a new file and then save it as portrait text. Okay, let's just say manual portrait, right? So so one thing that I remember from my high school computer class is you know, draw yourself. I think this is just to get us familiarized with the keyboard or something. Okay, so well, let's start. Okay, probably come down a little bit. We need a little bit of hair, and then yeah, so a little bit more hair, and even more hair. Okay, then I'll draw my ear a little bit, give it a little bit of an eyebrow. Okay, so that's my ear. Okay, and, let me see, that's my eyes. And maybe some nose. Well, maybe at this point it should have a little bit of a curve. With some mouth. And yeah, so that's my rough ASCII interpretation of my portrait. You know, I haven't even drawn my shoulders and stuff. So alternatively, you know, with reusability, with reuse, um, we can actually um, use npm packages here, right, to help us draw this. So there's one package called ASCII file image. So I'm gonna save. I'm gonna install ASCII file image. Okay, so here's me reusing the package, right? I'm just getting that package from the package repository, the npm package repository. Okay. Yeah. So with that, so think of this as a, from a developer perspective, right? So the next thing I could do is and start some more code. Generate.js. Okay, so I'm gonna ask ASCII image to generate a portrait of me, right? So in the spirit of reuse, I could actually even just copy and paste this from the page, the landing page for ASCII image, the package on npm. So here we are on the npm website. So we can then search for the package ASCII, okay, image. Okay, so this is the package that we are using, and let's see if we have some sample code. Yep, we do. So let's take this piece of code and put it back on our Visual Studio Code. We're just going to paste the code here. Right, for the width, I think we only need 18, and let's make the height 24. Okay, so for the path, we'll use the photo image. Okay, so let's try this out. Node generate. Cool. So this is how we get great developer experience. In this instance, this is me enjoying the use of the package. Okay. Developer velocity is also much faster. I'm just running the script. The quality and economy part is also pretty visual here. Let's take a look at my manual portrait. See, the portrait created by the ASCII image package is actually of higher quality if you compare to my manual one over here. And also, if you consider replicating the original copy as an objective and not creating an artistic interpretation. Okay, from an economy perspective, we are also actually reusing quite a lot of dependencies. If you open this up, these are the modules that ASCII image depends on as well. And also, as if looking that I'm actually requiring ASCII image here that my script depends on as well. So the interesting here is not just the economy that I gain by reusing these open source packages, but the economies of scale that these individual packages provide as well. So to understand this, let's go back to npm. If you look at the ASCII image package we use, it's downloaded 2,649 times weekly. So we can roughly assume that that's the amount of time it's used. And if you look at the number of people that's contributed to the code base, there's 3. So 3 people's effort reused 2,649 times in a week. If that's not economies of scale, I don't know what is. So one of the benefits of economies of scale is also related to quality. Let's take a look at another package, React. So React is used more than 8 million times in a week. That's pretty reasonable because it's used by many to reuse the J and M part of the JAMstack, the JavaScript and markup part, so they don't have to create their detailed JavaScript and markup. They just reuse components and such. So this also means that there are 8 million people testing the React package every single week. That's the kind of trial by fire that's made possible by this amazing mechanism. Next, let us take a look at API reuse. So JAMstack is about reusable APIs accessed over HTTPS with JavaScript. So the API can be in-house APIs that you code yourself, or it can be cloud services that you reuse. Now we know that using cloud services or in-house APIs are not new, but here's where JAMstack gets really interesting. For JAMstack apps, the reuse of the cloud services can typically happen between the browser and the cloud service directly. There's no need to take care of a middleware or application server in between. Let's take a look at an example. User authentication is one of the most common story in many applications. And with a JAMstack-based approach, what we can do is to get our app, I'll recommend a SPA or single page application, to interact directly with a cloud-based authentication service such as Azure Active Directory. Let's take a look at how to add such an interaction from a JAMstack perspective. This is a Next.js app that serves inclusive walkthrough. As you can see, this is a JAMstack app, and there's plenty of reuse here. I'm obviously using React to build my front end, but notice here plenty of markup as well. So I'm reusing tab content, tab pane, nav, nav item, nav link, card, button, card title, card text, roll call, all from React strap. That's quite a lot of reuse, but I'll show you there's a lot more reuse than this even. Here's how it helps, how the reuse helps. So here's where I create the tabs. There's 3 tabs: full video, topic snippets, and text only. And each of these on click will toggle a tab index. So this is the tab. These are the tab contents. So notice here the ID. So this is how the app knows which content to serve. Okay, let's start the app in dev to see how it looks like in the browser. Okay, here's the app. The Inclusive Walkthrough is an app that I'm building to serve walkthrough that are more inclusive. So what I mean by this is that I want to cater for as many people as possible by providing options that's best suited to their situation or preference. So for example, some people may like to go through the full video, but there will be some that want to jump onto individual topics in the walkthrough, so they can do so here. There may be those that want to go through a text-based experience, and they can do so here. Okay, so that's the app. Now let's get back to our earlier objective, which is to add an authentication mechanism to this app. Let's go through some reuse markup to see how the app can authenticate users using Azure Active Directory. Let's start with the nav bar here. So beside the docs item, we add a off nav item, which looks like this. Off nav item. So nav item is here. If the user is authenticated, we return a drop-down that allows the user to sign out. If the user is not authenticated, then we provide a button that triggers authentication. So off button method is a prop. So prop is a property that's passed in from this component's navbars container. In this case, it's authenticated. So within authenticated component, let's take a look at off button method. Yeah, here. So off button method is just simply something that points to log out if the user is authenticated and log in if not. So login itself is actually in auth provider. So login itself creates a pop-up for the user to log in and then gets the user profile after login. And that's it. Let's see how this looks like on the app. Here's the sign in button. If I click on it, a pop-up will appear for me to sign in. I will add another account to sign in with. This is my personal email account. And there you go. So once I've signed in, a drop down will appear, will be available for me to sign out. And that's it. If you want to go through the details of this integration, the code is available on this GitHub repository. I didn't build it, and you shouldn't need to as well. Let's reuse whenever we can. So this is an excellent example by these great contributors. And the code sample here itself will benefit from more eyeballs using it and logging any issues that we find, if any. Okay, while we are on this repository, it is also interesting to note that the tutorial that comes with this sample also shows us how to get an authenticated user's calendar. Here again we see how with JAMstacks we could use JAMstacks to build apps that has absolutely no application server or any server side, and the app still have the potential to be a feature-rich application. In this case, we get access to a user's calendar. Just with this example, leveraging Graph, a developer can actually access a plethora of functionalities within a user's Microsoft 365 ecosystem. So you can build a JAMstack app that has no server side but can bring together or access tasks, teams, calendar, groups, files, meetings, messages, people, devices, co-workers, and etc. Certainly makes me think about how to build apps differently in the age of cloud. Let's take a look at how we can interact with the Microsoft Graph API with just Markup and JavaScript, the JAM. Let's build another app. This app that we are building will be similar to the Inclusive Walkthrough app, but this app is about retrieving calendars and emails. Both are built with Next.js. The app that you will see is a bit different from this Microsoft Graph API sample code that's available on GitHub. The sample code is bootstrapped with Create React App, which makes it quite a standard React app. As we use Next.js, there's more framework in Next.js. Let me show you what I mean. And these are the things that you will probably want to take note of if you are planning on using either Next.js or plain React app. So you want to know the difference. So first, styles. So in the sample code for Graph, you have Bootstrap CSS included in app.tsx, and you have Font Awesome CSS included in navbar.tsx. So these are probably global CSS. So in Next.js, global CSS are included here in underscore app.js. So that's by definition. So that's one difference. The next thing to take note of with Next, pardon the pun, is that Next supports dynamic imports. With dynamic import, modules can be loaded dynamically by a page. This is really useful in situations like SSR, where server-side rendering, where you will serve the main page first and then dynamically load more components from the server. You can also load as you need it. So this is in situation like if something, then you load this component, and else you load some other component. So those are situations where dynamic imports are really useful. But this is different from dynamic imports. It's different from traditional imports, such as this one here in the code sample for Graph. So this is a traditional import. And when we import navbar, it's included at quote-unquote compile time. So it's not actually dynamically imported. There's one thing to take note of with dynamic imports though, especially in Next.js. At certain times, we do not want components, for example, authenticated here to be SSR, to be server-side rendered, because we are sure that this component will only work in the browser. So we can set SSR false for this component to get authenticated working. That's it. Moving on, let's see how we can get mails from the Microsoft Graph, right? So mail. Within a markup component-based approach, JAMstack, we go ahead and get the messages using the access token. So get messages. So here I'm adding a search function to return only mails that are related to news, because I don't want everyone to see my private mails here. So what getMessage does is that it calls the Graph API using the authenticated client. And this authentic client is not something I coded as well. It's something that I reused from, see, this is me initializing the Graph client. And the client itself is from the Microsoft Graph npm package. So I hope by this point you agree with me that JAMstack is a lot about reuse. And up to this point, all I've been doing is piecing together markups with JavaScript that calls APIs in the cloud. And I don't even maintain the API. Okay, anyway, back to our mail scenario. The mail data that is returned by the Graph API here, okay, is then rendered to the user. So we have it rendered as a table form over here. Let's take a look at how it looks like on the browser. So first thing, we'll have to sign in. Okay, once we're in, we can then retrieve mails. And there you go. Now let's take a look at JAMstack in terms of architecture. Let's start by going through a bit of history on the evolution of web application architecture. We'll start with one that has been around since the 90s, the traditional architecture. This was a time when the web was becoming popular, and the prevailing architecture at the time was responding to the need to adapt applications and practices that were previously used for developing desktop or internal applications to be more open to the internet. This architecture also caters for evolving needs around how security and functional separation is designed in enterprises. And governance and policies matured over time around this architecture. Team structures have also evolved around this architecture. For example, one logical structure is to have the network team having a major stake in the DMZ and the NVA. We then have the server team looking after the web tier, and so on and so forth. As things evolve, some organizations may seek more reuse, especially as cloud computing became more popular. There's many reasons for this, and it's typically related to the size of the enterprise, the team structure that they want to develop, and the potential for economies of scale. This architecture we see here fully utilizes cloud services and is primed for reuse. From a hosting and operational perspective, we also see a spectrum of potential reuse, especially with platform as a service and SaaS cloud services. But what does it all mean? I think the crux of it is focus. For what it's worth, the acronyms around the stacks, for example, the LAMP and the JAMstacks, is a good hint of the zeitgeist of the moment around when these acronyms became popular. For example, if you take a look at the key components of these stacks, in LAMP we have Linux, which is an operating system, Apache, which refers to the original Apache HTTPD web server, MySQL, which is the database, and PHP, finally the application. For JAMstack, we have JavaScript, API, and Markup, which are all logical constructs around the application. Remember, we're not comparing programming languages here, but more the concerns at the time when these stacks acronyms are introduced to the world. To summarize, what we can see is how a JAMstack approach can influence teams and how a JAMstack approach can influence the architecture. Continuing that focus around innovation on the application layer, momentum on the JAMstack brought us new ways of deploying applications onto the cloud. One of these is the single page application, or SPA. SPA actually describes a page that is requested once with subsequent content loaded without refreshing the page. Instead, new content are loaded via AJAX, WebSockets, or SSEs, server-side events. The interesting thing with SPAs are the practices that had appeared around the building of SPAs, such as having web application bundlers. So this web application bundler is typically part of the deployment pipeline. And for many frameworks and approaches to building SPAs, the web application bundler turns components, service wrappers, and other dependencies into HTML, JavaScript, and other browser-friendly static assets. So let's try to do this with the walkthrough that was shown earlier. The Next.js framework already contains a web application bundler. So what we need to do is to simply run npm run build. So this creates an optimized production build. This will take a little bit of time, but do note that you don't need to run this all the time. You only need to run this when you are deploying to production. For development, you could simply run npm run dev, and that creates an environment that auto reloads on the browser. So what we'll be expecting is the size of the assets that are generated. As you can see here, we can see that the first load.js is 62.7 KB. Okay, so this generates an exportable app, right? So the next step that we're going to take is we are going to export the app. So npm run export. So this creates static HTML and assets that we can deploy without having a Node.js server that actually hosts it. So we can actually deploy this to Azure Blob Storage. So now we run npm run export. And yeah, we can see the output being generated here. So these are plain HTML and JavaScript that can be served without a Node.js server, and therefore we can actually just serve this as static blobs on Azure Blob Storage. We can deploy to blob storage quickly with the Azure Storage VS Code extension. So with that extension, we can simply right click here and do deploy to static website via blob storage. Create a new account. Okay, give it a unique name and it will start creating. So once it's ready, you can actually click on browse to website, and this will turn on a browser, and we should be able to see the asset being served here. There you go. And that's it. Now let's take a look at the blob storage that's created on the Azure portal. So inclusive of true. So we know by default that it was created in West US. Okay, it's a standard tier blob storage. The replication setting is LRS, locally redundant storage. The access tier is hot. The account kind is general purpose V2. So that's the default setting. Of course, you can also go through the advanced process to have customized value for each of these as well. But now let's see how much this cost. So let's, this is the pricing calculator. Let's add a storage account. Interesting how we are deploying an app and the only price consideration that we are looking at right now is storage. Let's change these settings a bit. Region, we know that it's West US. It's blob storage. Performance tier standard. Storage account, general purpose V2, redundancy, LRS. Access tier hot. So this is the exact setting that our storage account have over here. Okay, so now let's tweak these figures a little bit. So total storage that we use to deploy our app, I'm sure it's less than 1000 gig. It's probably 1 GB. I mean, probably less than 1 GB. But let's have it as 1 GB because it's 2 cents for now. So for write operations, we need to consider the number of files that we need to write to blob storage per deployment. So to do that, we need to first consider the number of files that will be generated by Next.js through Webpack upon getting ready for deployment. So one thing to consider is chunking. So when we run export, Next actually generates these chunks of JavaScript, and this is actually a strategy to allow the app to load faster on initial request. So what happens is the not all JavaScript will be sent to the user, only specific chunks that are necessary for the initial load, and subsequent chunks of JavaScript can be loaded as and when it's necessary. So let's say we get about 100 chunks, so 100 files per deployment. Going back to our calculator, so if you want to do like one deployment a day, 100 files per deployment, doing that for 30 days, so that will be 100 times 30, which is 3000. Okay, so 3000 write operations. For list and create containers, I don't think we'll use that list and create that many times. So let's just have it as 1,000. For read operations, again, assuming that we have 100 chunks and assuming the worst case scenario where a user requests for all 100 chunks, so that gives 100,000 here, gives us 100 chunks, gives us 10,000 serves, right? Page serves. So let's say we want 100,000 page serves. We can actually then increase this to 1,000,000. So if you want to use a CDN, this gets reduced, right? So the read operations here is used then to fill the CDN caches. But let's just assume this as 1,000,000 for now. It's anyway 44 cents. Okay, let's consider the next thing, which is all other operations. So doing this deployment via Next.js and our strategy of actually using blob storage to serve the app, right? We'll probably need to assume that the files that will be generated, the chunks that will be generated, will be quite different for each deployment. So we'll need to delete those chunks, those files. Let's say 100 files, all of them gets wiped. So we'll need to wipe that every time we deploy. So let's have this as 3,000, similar to write. So this is for deployment purposes. Okay, data retrieval and data write is actually free for blob storage. So we could go up to say 5,000, right? 5,000 retrieval and 5,000 write, and the cost remains the same. So monthly cost is currently about 50 cents. Yeah, pretty good if you ask me. We can also add a CDN if the workload has high bandwidth requirements, or if you want an easy way to serve a global audience with a closest point of presence, or for a few other route optimization advantages. Let's quickly add an Azure CDN from within Azure Storage itself. So we can quickly do so from here. Create a new profile. We'll call it inclusive. So a profile is a collection of endpoints. For pricing tier, we'll use standard Microsoft CDN. For endpoint, call it inclusive walkthrough. And for origin hostname, that's going to be the one. Yeah. Actually, we should use the one for the static website. Okay, once we're done, we'll click create. And that's it. Let's take a look at the pricing of the CDN that we've just added. So CDN provider Microsoft. Yeah, a CDN is charged based on the amount of data that is transferred through the zones here. So now let's take a look at our app. So we know that first load is about 62.7 KB, let's say 63 KB, and let's just say we want to consider a deployment for 1,000,000 first loads in a month. So let's go back to, so 1,000,000 first load at 63 KB will be 63 million KBs, which is 63 gig. Okay, let's assume 65 gig. Let's round it up to 65 gig so that we can divide it equally among these 5 zones here at 15 gigs per zone. And that adds up to 1097. Yep, so about 1145 per month for the CDN and the blob storage that we use. Now let's take a look at accessing our website through the CDN. So let's get back to the CDN. So this is the host name, inclusive walkthrough, and if we go on to the new URL that we have, yay! So we have inclusive walkthrough served through the Azure CDN. One more thing that I want to show you is how to modify the app. So you need to modify some part of the configuration part of the app and another part on Azure AD itself to adapt to the new URL that we have for the app. So this URL goes through the Azure CDN, as we know. So before moving on, let me show you what will happen if you don't modify that. So let me try to sign in. So I'm going to sign in with my personal account. So I'm going to approve the sign in. Okay, it's approved. Yep, so notice how it actually redirects to localhost 3000. So this was the URL that will work when it's in local development. But now that we have deployed to blob storage and subsequently even to have the app accessed via the CDN, we now have to actually change the URL to this new one here. So first let's close this. Okay, so we cancelled the sign-in flow and let's head on to Azure. So accessing Active Directory, app registrations, we need to look for WebHam, which is the name of the app that I've registered. Okay, so we go to Authentication and we change this to the new redirect URI. Okay, so this passes and save. Okay, next we need to change the configuration on the app site. The configuration to authenticate with Azure AD is actually available in the config constant over here. The app ID, redirect URI, and the scopes, these are used by the authentication component as part of the flow to authenticate with Azure AD. So we'll need to change the redirect URI over here to use the new URI we have, and we need to redeploy this app to blob storage. As we've already seen that, we'll skip that part and jump fast forward directly to post deployment. Okay, now let's try to sign in via the app that's served via Azure CDN, inclusive walkthrough.azureedge.net. So I'm going to sign in here. And yeah, I have an account here, so let's just use this. And yep, remember how we can only sign out once we sign in. So this indicates that we're signed in, and that's it. Okay, I think I'll stop here for now to conclude and reiterate what we have gone through today. And most of that revolves around how the reusability encouraged by JAMstacks can benefit things like developer experience, developer velocity, architecture best practices, cost efficiency, and finally innovative economies of scale leveraging on cloud APIs such as Microsoft Graph. Thank you.